Some fantastic talks at this conference, very informative and interesting. Today I'm going to be discussing the benefits of combining additive technologies, specifically combinations of FDM and direct ink writing. I'll show some real-world examples of that combination, and then I'll be talking about direct ink.
If you try to keep even this mic, use this mic, and
sure, or maybe
some noise from the fan.
Okay.
Or close to this one in some way.
Is that okay? Okay. Is this better?
Yeah, this is better.
Yeah. Okay. Thank you. So also the combination of direct ink writing and nano deposition. So I'm sure everyone here is probably aware of FDM, or fused deposition modeling, thermoplastic extrusion. It's a very common, very reliable, very well-known technology. It's easy to learn and operate. There's diverse materials available for the technique, although limited by the filament type form factor. And it's cost efficient. Direct ink writing is ink paste microdispensing. Here we are referring to kind of a piston style mechanically driven mechanism. Advantages of this approach is that you can print materials with high viscosity, and so you can print at high speed and high volume. Nano deposition here is referring to materials transferred from a nanoscale tip to the surface, allowing you to print very high resolution down to 50 nanometers, and it's also a reliable deposition technique. So here we have combination of direct ink writing and FDM in one system. The FDM can print kind of a standard materials, PLA, ABS, PETG, carbon fiber, flexible TPU materials, and more. The Printhead 2 is the materials dispensing direct ink writing system. It can dispense conductive nanoparticle materials, inks and pastes, polymers, hydrogels, dielectric materials, semiconductor materials, materials with sensing qualities, organic materials, energy capture, resistive inks, magnetic graphene, and more. Lower left image here, we have RFID antenna being printed with silver ink on PLA. So with the system that combines direct ink writing and FDM, new capabilities are available. With direct ink writing and FDM, you can make a combined technology system. You can, some advantages are you can dispense more material per second than inkjet or aerosol, creating single pass conductive traces. You can dispense highest viscosity materials of any ink paste dispensing technique at speeds upwards of 300 millimeters per second, and it doesn't require an electrically conductive substrate. System features independently moving print heads to increase precision and eliminate cross-contamination. This improves quality, accuracy, speed, and reliability. It is a large format build volume, 360 by 250 by 200 millimeters. And the images we have a circuit design with interconnects and contact pads, where the contact pads are spanning 4 millimeters in height from the lowest pad to the highest pad around the object. We have an inductor coil for wireless charging. You can kind of see the blurrier layer here is one layer removed from the coil layer, and there's a vertical via in the center position, and then the entire device is embedded in PLA. You can also make a multi-layer device with just the dispenser system alone. Here we have copper traces printed on a PET substrate and then embedded in a layer of silicone, and with vertical interconnects to a graphene circuit on the top of the device.